Guys, so welcome to class. So let's go ahead and get into this problem. And this is a part of a packet that we got. And the title is Characteristics of Quadratic Equations 3B.2 Practice. So hopefully you can find that. I also have a copy of it in eClass in the news item, so you can download that if you need to. So let's go ahead and start the problem. It says Wile E. Coyote, I hope you recognize that character from the cartoons, is catapulting a boulder off a cliff to hit the roadrunner. So Wile E. Coyote is up here at the top of the cliff, and the roadrunner is somewhere down here. Okay, so Wile E. Coyote is up here, and the roadrunner's down here. And so, as always, he's always trying to get the roadrunner. And so it says here that T represents the number of seconds that the boulder catapults off the cliff, and H of T denotes the height of the boulder in feet above the base of the cliff. Ignoring air resistance, we can use the following formula to express the path of the boulder. So this formula, if you were to graph that in your graphing calculator, if you don't have one, go to Desmos.com and graph it there, and it's going to make this image right here. So the first question says, what does the x-axis represent? So they tell us that h of t represents the height. And so this is a function right here. You might be used to seeing something that says f of x or g of x. So this t is just like an x. That's always our independent variable. So this is t, so that represents time. Okay, and the y-axis, this is the y-axis. Let me erase this. Okay, this is the y-axis. That represents height. So this is time, t, and this is h, height. Okay, so that's the y-axis. So height off the ground. Number 2 says, what part of the graph is insignificant and why? So this part, everything left of the origin, everything left of 0, or for every part of the graph where x is less than 0, that's the insignificant part. And the reason why, well, these numbers are negative. -1, -2, -3, and so on. And if you have negative numbers, and we said that this axis represents time, well, is there negative time? No. You can't have negative time. Hey. Okay, so sorry for that. Had a little interruption. So anyway, you can't have negative time. So I think I kind of wrote that wrong, so let me fix that. You can't have negative time. That doesn't make sense. And really, if we're going to get specific, these numbers here would not be part of our domain. They're not a reasonable part of our domain. So our domain would be the x values greater than 0. Now, question number 3 says, what was the height of the boulder before it was launched? So remember, this is where Wile E. Coyote is. He's at the top of this cliff right here, and he's about to get his catapult and launch the boulder up into the air. So if we read this point on the y-axis, that's at 160 feet, because they told us we're in feet. So the height of the boulder before it's launched is 160 feet up in the air. It says, what special point on the graph is associated with this information? So if you notice, the coordinates of this point are 0, 160, and it's where the graph is crossing the y-intercept. And so you may have guessed, I'm sorry, I gave it away. It's where the graph is crossing the y-axis, so hopefully you recognize now that that's the y-intercept. That's why I'm not good at telling jokes. I always give the punchline too soon. Okay, let's look at number 4. It says, if Wile E. Coyote simply pushed the boulder off the cliff, how would the graph look different? Okay, guys, just use your brain, put your thinking caps on, use your imagination. So remember, a catapult sends the boulder up in the air first, and then gravity is going to cause it to come down, right? So what if he just pushed it? It's not going to go up in the air. It would just kind of go out and then come down. All right, so it might not go as far. I don't know. I'm just guessing, but it would look a little bit different. So it said, the question said, how would the graph look different? So we could say something like, the graph would not rise. It would only fall or drop. Okay, so hopefully that makes sense to you. Again, it's just going to go out and then come down, right? Okay, so let me erase that so that doesn't confuse us later. So number 5 says, how long will it take before the boulder reaches the bottom of this cliff? So how long? How long? All right, well, that's a unit of time. We're talking about time, and we know that we were told earlier in the problem that we're measuring time in seconds. And so it says before the boulder reaches the bottom of the cliff. So basically this is asking, how long will it take for the boulder to reach the bottom of the cliff? Well, where is that? Well, that's down here where Wile E. Coyote is. Okay? And so if the if the rock or the boulder is coming up in the air and then it's coming down and it hits the ground here, and this is time, well, that's 1, 2, 3, 4. So it would take 4 seconds. Okay, and the next question says, well, what special point is associated with this information? Okay, so what axis is this? Notice this is the point 4, 0. All right, so the y value is 0, and so that tells us that's the x-intercept. This is where the graph is crossing the x-axis, so that's the x-intercept. Number 6 says, after how many seconds does the boulder change direction? So where is it changing direction? So let's go back and follow the path. It starts here, and then it goes up, all right, and it looks like it goes up here, and then it starts changing directions. So that's not exactly at 1 second the way I'm reading it. I don't know, I didn't graph this on a graphic calculator, so hopefully the graph up here is correct. I think it is. But I would say that's a little less than 1 second, but a little more than a half. It's kind of, it's your call. But I would say that that was maybe 0.75 seconds. All right, that's my read on it. The second part of number 6 says, how high is the boulder? Okay, so remember, time is what we measure along x. So let me go back for a second to show you where I got the 0.75. So this is where it turns right here, and then I just drop that down so I hit the x-axis because I like time. And then the next question says, well, how high is the boulder? Well, when it reaches its highest point, that would be right here, but I want to go over height is along the y-axis, and it looks like we're counting by tens, so that would be 170 feet. So it changes direction at 170 feet. I wrote 175. I meant to write 170. Okay? Number 6 goes on to say, what is this significant point called on the graph? This point has a name. What is it? Do you remember? If you said vertex, you are correct. And incidentally, is it a maximum or is it a minimum? Okay, remember mountain high? That's the high point, so it's a maximum. Hopefully all the little things that we talked about are coming to mind. Number 7 says, how high above the starting point does the boulder begin to change directions? In other words, what's the difference between where it started and then that highest point that it reaches before it changes direction? So how much higher? Well, that would be 170 feet, take away 160 feet, which is 10 feet. So it's 10 feet higher than its starting point. And then number 8 says, if Wile E. Coyote changes his mind, how many seconds does he have to stop the boulder from going over the cliff? All right. So, if he was going to stop it from going over the cliff, well, that's a tough question.